Okay guys, it's time for statics review.
First up, we got 2D reaction problem. So this one, super easy. We're looking for the reaction at C, and we have force 1 given, force 2 given, these distances, and the height. So to do that, we're going to start with the moment at C. So the moment at C has the perpendicular forces on it. So we have this one, this one, this one, and that one. Sorry, I let it go away. But so this one is split up along this. So it's like that. So we can use all those forces. So to do that, we're going to do the tension in AB times cosine of the angle. We use to get this angle, we use arc tangent. So then we use the height in that. Then we multiply it by the perpendicular distance. So it's clockwise. So our forces are going to be negative. So it's going to be negative forces. And then it's the perpendicular distance to those forces. So once we do that, then we get the tension. Then from there, we are able to do sum of forces to get the reaction at C. If we need to do the reaction, it's just going to be Pythagorean theorem and then another tangent. So next up, we have one of these 3D moment questions. What we have is we're given all of the distances. We have this cable, oopsies. We have this cable right here, and we have this distance right here. So what we're going to do first, we're going to make our points. So A is at 0. I didn't really want to put 0. I don't know why, but it's 0, 0, and then it's the distance, this distance. So then this one is Z1, which is this distance, and then 0, and then this distance, and then D is up a little bit, so it's this distance plus this distance, the height. Next, we make vectors out of them. So we do distance from A to C, we have this, and we have the distance of A to D, and then we do that, but then that's our vector, but because we have a force associated with it, we multiply it by the force, but then we're just going to have a crazy big number that's not going to mean anything, so we have to divide it and make it a unit vector. So to do that, we divide it by its magnitude. So what this equals out to, like, we can rewrite this as 0 over the magnitude of AD. Like, that would be another way to write it for our I value. So then we're going to get two vectors, and then we're just going to take the cross product of them, of AC crossed with AD, and then we got our answer. Next up, we got method of sections, super easy stuff. So we got this, so we have a pin on this side, and then we have a roller on this side. We have roller and pin, and so we're going to start and treat it as one rigid body. So we'll kind of treat it like that. We have force here, force here, force here, force here. We're going to start at the moment of A, do the moment. Again, force is clockwise, so it's going to be negative. And yeah, so then we can do that to solve for AY. We can do that to solve for FY, little f, and then we can use sum of forces of Y to solve for AY. Next, we can section. What I like to think of is it's like this. We want to find this one and this one. So how we would do that is we would cut it through there. That way these ones all become forces rather than actual lines. Not this one, but they all become forces rather than actual lines. So that's where we cut it. So we cut it here, and then we just have our points for reference because we will be taking the moment of them. So if the angle's given, then we're going to use tangent to find the height. If the height's given, just use the height. So now we're going to take the moment of the joints with the most unknowns / what's it not is touching. So the one with the most unknowns is B. So if we take the moment at B, all of these forces don't matter. So we're only really looking at this one, and that one. So that's what we do. So we take the moment at E, because this one has this force and this force. So I'm just going to start at E because then we have one known here. So this one, what it's not touching this one. So now we can solve for BD. So to solve for BD at the moment of E, we do blah, 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 solve for BD. Then we can take the moment of B, because we know this one, we're just going to do the same thing just for this, because we don't really care too much about this. It's not in the question. But if we did care, then we can use the sum of forces to use, and then we can use cosine of that just to find the x. If not, if we have to like do the whole thing out, we can use like the components of it to get our values. But that's boring. That's how we do that one. Next up, we have our moment of inertia. So this I-beam is split or three shapes. So we have this shape, this shape, this shape, and those are our three. We could also do it as three. We could do one big one and then subtract these two, but that's a little harder, so that's not the way I want to do it. So our first rectangle, second rectangle, and third rectangle are all right there. And then we're going to use h1 times the height one. So height one is y3 times x4, and then fill out this table. So our x bar is going to be our centroid. So we don't care about all those fancy shapes. So it's just the middle. So it's going to be whatever y3 over 2 is, and then so it's each individual shape, but it's in relation to the origin. So once we do that, we're going to multiply this one here and this one here, and once we do that, do x of a, y of a, we add them all up, and then we divide them by the total area to get the x bar. Next, now with our x bar, we're going to take the distance to the centroid. If it's not the centroid and the question asks for an axis or something else, then we're going to use the distance to that point. So we have the distance to the centroid, so we're going to take each individual x bar and subtract it from the main x bar. Y bar, same thing. Then, given the table, we're going to have these, which are our moment of inertia for each of the shapes. So it's on the x, it's base height cubed over 12, and then it's just the opposite for y. Once we do that, we're going to plug that into our equation. So the x bar, or moment of inertia prime, times the area times the distance that we just calculated squared. So some of these distances will be negative, and it doesn't really matter just because it's distance and it's going to be squared, so it doesn't matter. If we were to do it the second way that I said, when we subtract these two spaces, then we would subtract them here. So this is our total final answer. If, say, we did it that way, it would be ix1 minus ix2 minus ix3. But who cares? I did do some extras just in case, but who cares?